vertex of the parabola. So that is either the highest point or the lowest point. So if we have an XY chart and we were to graph the parabola, first of all, just thinking about it, is this an upside down smiley face or upward facing smiley face? Upside down, there's a negative in front of x squared. So we know it's a quadratic that looks something like this, right? So we're finding the vertex, either the highest point or lowest. In this case, the highest. So I give you the x value for the vertex is on the axis of symmetry. So we can find the x coordinate of the vertex using this formula. So first of all, a is equal to, b is equal to, and c is equal to 3. I always write that first. Then I go through and say, okay, here's my axis of symmetry. So that's my x coordinate of my vertex. So the opposite of b would be positive 6, right? Divided by 2 times negative 1, right? So on top, just write out your work, because if you don't type this into your calculator with parentheses down here, you're going to get it wrong. So just write it out. 2 times negative 1 is negative 2. 6 divided by negative 2 is negative 3. Okay, so that's just your axis of symmetry. So you have negative 3, comma, question mark, right? Because the vertex is an xy point. Now this is what I'm seeing on some people's bell quizzes. They stop at negative 3, but that's not the vertex. That's just the x coordinate of the vertex. So you would have got it partially, right? So I'll give you most of the points. So now we plug in, we want to know what's our function at negative 3. If we want to know what's our function at negative 3, we plug in negative 3 wherever there's an x into our function. We've got to do this very carefully. So negative of negative 3 squared, right? Is everybody following me? Seems to be the hardest part for most people. Minus 6 times negative 3 plus 3. Then type it into your calculator exactly as such. I'm fine with you typing it in as long as you type it in exactly how I wrote it like this. So if you type it in, negative, parentheses, negative 3, close your parentheses squared, minus 6 times parentheses, negative 3 plus 3, you get positive 12. So you get 12. So our vertex is at 3, comma, negative 3, comma, 12. How many of you got 100% correct? Good job. Good. How many of you made a little error? You're seeing where maybe? Okay, good. As long as you're seeing where. So you've got to get really good at that. Yes?
So if you always put the negative 1 out to the side from you?
Yeah, if they say, yeah, good. So good point. There's technically a negative 1 right there, right? And that piece is not being raised to the second power. So that's why we have to write it out front. Good question. Okay, so what we're learning today is couple things. Well, first of all, let's talk about this. So we know that the standard form of a quadratic is ax squared plus bx plus c, where a, b, and c are the coefficients in front of the variables. A is always in front of x squared, b is always in front of x, and c is always our constant coefficient. So this is a quadratic in standard form. What's my a value? Just question. What's my b value? And my c value is? 2. Good. A value? B value? 0. And good. C value? -0. Good. A value? 3. B value? -2. And C value? 0. Good. So we are able to identify ABC. Once again, this is standard form of a quadratic. There are different forms of a quadratic, so understand this form, ax squared plus bx plus c, is standard form of a quadratic. Okay, I want to say this before we get started. So insert blank page. So we know quadratic can be represented as a function. So f of x is equal to x squared, for example, plus 6x plus 3, right? So we can represent a quadratic as a function here, written out as an equation. And you can also represent that same equation as a graph, right? Everybody, we know it's a quadratic. Isn't this equal to this? It's just different forms of writing it. Yes. So could I also write this as a bunch of xy points? Isn't there just a bunch of xy points here? Right? There's just a bunch of xy points. So I could also write this as x comma y, a bunch of x comma y points. X comma y, right? So I could write out a bunch of points as well. So do you guys understand that points can be written as graphs, can be written as equations. Equations can be written as graphs, can be written as points. So it's all an apple. This is applesauce. Apple is apple juice. There's different forms of writing the same apple. Okay, so I just want to go over real quick. Let's go through and do this problem here. So let's graph this. So given f of x is equal to 3/2 x squared plus 6x plus 2. We're going to go through and graph this just so we don't forget how to graph the next few days. So the first thing we do is find the axis of symmetry. X is equal to the opposite of b over a. A is equal to 3/2, right? B is equal to 6 and c is equal to 2. So our axis of symmetry is -6 divided by 2 times a. A is 3/2. So on top we have -6. Yeah, a lot of you don't know how to do that, so do it in your calculator. 2 times 3/2, go. Everybody should be doing it. Remember that no longer is it acceptable for you to sit there and watch me do it. 3, awesome. What's -6 divided by 3? -2. So are you going to let fractions scare you? No, okay. So we have our axis of symmetry at -2. So we're just going over this so that we don't forget how to graph, because we'll have a test coming up in the next week and a half, 2 weeks. Okay, now we know that axis of symmetry, we're going to find the vertex, highest point or lowest point. So we know it's -2, comma, question mark. We're going to plug in -2 into our function. So 3/2 times -2 squared plus 6 times -2. Type it in, guys, so we don't have to spend all day graphing this. So 3/2 times -2 squared.
-4.
Okay. Everybody's getting -4. Yep, I got -4. So -2, comma, -4. So I go to -2, -4, there's my highest or lowest point. Okay, it's my lowest or highest, can you tell me?
Your highest. I made the lowest.
Isn't it our lowest because it's a smiley face?
Right.
A is positive? Okay, good. Our y-intercept is always when x is equal to, when's it crossing, what x value is it crossing the y-axis at? 0. Plug in 0, what will we get?
Plus 2.
0, comma 2. If we plug in 0, that becomes 0. Plug in 0 here, it becomes 0. 0 plus 0 is 0. 0 plus 2 is 2. So it's crossing at 0 up 2. It's crossing the y-axis at 2. And then 2 other points on the graph. So we could plug in for x equals 1 and 2 if we wanted. Whatever you want. So I'm going to plug in for x, comma, x, y. I'm going to plug in 1 and 2. So you give me the function at 1 and 2. Go. 3/2. So when you plug in 1, you got 9.5. That's good. And if you plug in 2, you get 20. So I go over 1 up 9.5. Boom. I go over to 2 up to 20. So clear up here somewhere, right? Now I can draw on this side of my parabola. And then we know it maps evenly across the axis of symmetry. So if we are 1, 2 away from the axis of symmetry for this point, we're 1, 2 away this way. If we're over 1, 2, 3 from the axis of symmetry this way, we're over 1, 2, 3. And then vice versa, same thing up here. So I can draw my nice pretty U here, which isn't that pretty. So we're all good with graphing, right? It seemed really hard for us the first day. Now it's not so bad, right? Okay, so let's get to what we're doing today. I just didn't want us to forget how to graph. Okay, so my question is, looking at the graph, can you tell me the axis, the y-x? Okay, a couple things. So you tell me, look at this graph, guys. What is the y-intercept? At what point? Look at it and talk to your neighbors. Ready, go. So what did you come up with for the y-intercept?
0, -2.
0, -2. Isn't it crossing the y-axis right here? Isn't that 0, -2? Did everybody get that? Okay. What is the axis of symmetry? An axis of symmetry is always x is equal to something. So x is equal to -1. Isn't that the line, the x value that our parabola is symmetric across?
Yep.
Ding, 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 ding. Is everybody comfortable with that? So can you go backwards? What is the domain and range? So what's the domain? Domain's x values. Where's it growing? From left to right. Negative infinity to positive infinity are all real numbers. And our range, so I'm going to write it both ways just so we're getting comfortable with both. And our range is y values. What's the lowest point? Our function starts out on the y-axis. Lowest point that our function starts at. -4 is growing to positive infinity. Did it touch down right at -4? So it includes -4. Infinity always gets parentheses. Yes.
When would you ever not touch it before?
Great question. If this was a graph with an open circle right there, because that would mean it doesn't include that point. Does that make sense? So you'd still write -4, but you'd put a parenthesis because it doesn't include -4. Does that make sense? Good question. All right, so what we're learning today, here we go, 6-3, modeling with quadratic functions. This is one of the easier days for sure. So just like we talked about, quadratics can be represented as an equation, or it can be represented as a graph. Well, if it can be represented as an equation or as a graph, then it has a bunch of xy points. Now, if you have a bunch of xy points, then you can find a quadratic that models those points. The n+1 point principle. So this is something that you actually learned in secondary math 3. I decided to share it with you now because it will make sense with what we're doing today. So the n+1 point principle means if you have n+1 points, so if you have n+1 xy points, the degree of the function is n. So once again, if you have n+1 points, the degree of the function is n. So basically, if you have a bunch of points, let's say you have 5 points, it's 1 less than that degree. So if we have 5 points, it's degree 4. If we have 3 points, it's degree 2. If we have 6 points, it's degree 5. Does that make sense? If we have 2 points, then it's degree 1. Does that make sense, everybody? So once again, if you have 3 points on a graph, then you can have a degree 2, a quadratic that models those 3 points. Okay, so it says, write the equation of a parabola. So it says, once again, you see the word parabola, so you know it's quadratic. Now really, that's more what we're getting into today, is in the instructions it tells you it's a quadratic. So once again, it says, the parabola contains these points. So you know it's a quadratic. Does that make sense of how we know it's a quadratic? Okay, so it says, the parabola contains the points 0, 0, -1, -2, and 1, 6. What is the equation for this parabola in standard form? So if you think about it, we have an XY chart here. You don't need to do this part, just look with me. We have our point 0, 0, we have -1, -2, and we have over 1 up 6. So we have this quadratic looking something like this. So it's coming out this way, right? So it's probably going to, we don't know for sure if it's going to continue down. We don't know if this is the lowest point or highest point, right? So I mean, it could keep going down, but most likely it comes back up. Does that make sense, everybody? So we're looking at this quadratic. Well, your calculator actually will do it for you, so that's how I'm going to teach it to you. There is a longer process to do this. I make my secondary 3 kids do it by hand, but we are run by a technology world, right? If you're in the real world, do you think you're going to be able to use a calculator? Yes, in fact, they will urge you to, so you are precise. So I'm just going to teach you how to do it with the calculator, and in this class, at this level, it is fine. So everybody get out your graphing calculators, pull it up. So you have the points. 0, 0, -1, -2, and 1, 6. So first things first, these are x, y points. X, y, x, y. So my x values are 0, -1, and 1. My y values are 0, 2, and 6. Does everybody see how I wrote that? Okay, so pull up your calculator. Follow me through this. So you're going to pull up your calculator. You hit the stat key. So if we want to know what quadratic matches those points, your calculator will do it for you. Everybody hit the stat key with me. I'm going to wait. Does everybody have the stat key ready? Hit the stat key. Now you're going to go into edit. So you're going to go into edit. So hit enter. In list 1, you're going to type in your x values. Once again, in list 1, you're going to type in your x values. In list 2, you're going to type in your y values. Now, they have to match up. So now notice something. First of all, with these lists, you can't hit clear. It doesn't work. Oh, well, I guess, let's see. Does it work? No. You have to hit delete. So if I want to delete some of these things out here, come on. So I hit delete. This is the delete key. I'm deleting them out so I can have it fresh. Delete. Now make sure you don't delete the lists. If you want to accidentally scroll up here and delete list 1, it's going to be all messed up. Do not delete list 1 or list 2. So make sure you're being really precise. Delete, delete, delete. Now let's all learn something real quick. Let's say you do something really weird to your calculator. You have to know how to fix it, right? If you're on an ACT and you're like, what the heck's going on with my calculator? I've done something weird. There's not going to be Miss Christensen there to help you. So let me show you how to reset your calculator. Today's an easy day, so you won't have homework. So we should learn these things. So everybody, you've had many of you have had me just come and reset your calculator. I haven't taught you how. So resetting your calculator just brings your calculator back to the most basic things. So like if you bought it brand new, all the basic setups will be set up for you. So let's say you do something weird to it, like on accidentally delete a list, you would reset your calculator. So everybody follow me through this. You have to hit the second key. So second, and then the plus sign, because see how it says memory? MEM means memory. So second, plus sign. Did everybody do that? Let's all reset our calculators right now. Now I go down to number 7, which says reset. Did everybody follow me? Second plus sign, down to reset. Now it says, do you want to reset all around? So that just means all the stuff that's in the calculator right now, do you want to reset it? So I say all around, enter. Now it says, do you want to reset? You have to scroll down to yes. So you want to reset it. So now I have this brand new, beautiful calculator with nothing missing. Is everybody good with how, if you mess up your calculator, how to fix it? Okay, so now I'm going to go back to stat. So I go stat, and then enter into edit. Now in this one, we're going to type in our x values. So our x values were 0, hit enter, -1. Make sure you don't type in -1. It's got to be -1, hit enter, and 1, hit enter. Do you see how I typed in the x values? Now you got to scroll over. Your y values have got to match up or you won't get the right quadratic. So our y values, the one with 0 was 0. So I hit 0, enter, -2, enter, and 6, enter. Now make sure there's nothing else in here. There's not. They line up, and once again, if you needed to delete something, you have to hit delete, not clear. So we're used to being able to clear, but with the list, you have to hit delete. So now, is everybody good up to here? So now you hit stat again. So you hit the stat key. Now instead of being in edit, we go over to calculate. So scroll over with your arrow keys. Over to calculate. Now look down here. Number 5 says quadratic regression. Quadreg, which means the quadratic regression line, which simply means the quadratic polynomial. So we want it to be a quadratic because our instructions told us it was a quadratic. So we go down to quadratic, hit enter. It brings you into something like this usually. I hit enter, just enter through, because it's saying you're using list 1 and list 2. Enter, enter, enter. I just enter through all that. And guess what? It gives me the quadratic regression line, the quadratic polynomial that matches those 3 points. So we know our a value is 2, our b value is 4, and our c value is 0. Remember, a is in front of x squared, b is in front of x, and c is our constant. So it's going to be 2x squared plus 4x plus 0, right? So 2x squared plus 4x. So 2x squared plus 4x. That is the quadratic that had these 3 points. Does everybody understand how to do it? Do you need another example? Do you need another one to see like how to do it in your calculators? You're sure? Okay. So if you saw S point, you can do it. X, Y point, you can do it. No questions? Okay. So go through 1 through 1 through 10 on the worksheet. Oh, really? You should be able to go 1 through 12 on the worksheet. Some calculators are a little bit more precise than others. How many on number 7 got their a value was -1, their b value was 5, and their c value was 4.5, and then it has an e to the -13. Okay, if that's the case, let's think about it, guys. So we have 4.5, e means times 10. So times 10 raised to the -13 power. So if we were to write that as a decimal, we would say, okay, so 4.5, we're going to move the decimal back 13 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 0.000000000045, right? Isn't that our decimal? Isn't that what this is, but written as a decimal? Okay, that is like basically 0, is it not? It's teeny, right? I mean, it's so close to 0 that we'll call it 0. Does that make sense, everybody?
So the C value would be 0.
So C value would be 0 in that one. Yeah. Listen for a second. So now here's the reason we care. So why do we care about having the equation? So once again, why do we care about having the equation? Well, that's so that we can figure out any x value. We can figure out the output for any x value. So if we're given a bunch of points, so if we're given a bunch of points like this, and then we're asked, what's the x value at 10? We're not going to be able to find it, right, unless we have an equation to plug it into, right? So that's why we want to know the quadratic equation. So let's read this problem here. It says, a man throws a ball off the top of a building and records the height of the ball at different times, as shown in the table. So he drops the ball off the building, and he records the height of the ball at different times. So at 2 seconds, it was at this height, at whatever. At 0 seconds, he was up at 46 feet, right? Everybody?
Yeah.
And at 1 second, it was 63. At 2, it was 48, and at 3, it was 1. So it says, find a quadratic model for the data. So once again, that's how we know we're using quadratic. So let's go ahead and do that. Type it into your calculator really quick. Here we go. Okay.
It says in this map.
Well, I would pick that, so it's like
So you have y equals negative 16x squared
plus 33x
33x
plus 46.
plus 46. So this is the quadratic model. Did everybody get that? A was negative 16, B was 33, and C was 46 when you typed it into your calculator. Okay, so now we know the equation. So now we can find many things about the quadratic. It says, let's do B first. So B says, use the model to estimate the height of the ball at 2.5 seconds. So now we want to know what's the height of the ball at time 2.5. So are we looking for the y that matches that 2.5?
Yes.
Yes. Isn't this height? Yes. So how do we find that? Just by plugging it in, right? Negative 16 times 2.5 squared plus, type it in, 33 times 2.5 using parentheses plus 46. Type it into your calculator as such, and what is the height? 28.5? Is that what you got? 28.5. So 28.5, did everybody get that? So it's at 28.5 feet. I'll believe you. I don't have my calculator to check it, but if multiple people got that, then we're probably good. So now we'll do C. It says, what is the ball's maximum height? What does maximum mean? We're finding the vertex, right? Aren't we finding the vertex when it says max or min? So we find the vertex. We take x equals negative b divided by 2 times a. So the opposite of b would be negative 33, right? Divided by 2 times a. A is negative 16. So go calculate it. Negative 33 divided by what?
Negative 32.
Negative 32. What do you get?
1.03125.
1.03125.
125.
Awesome. So that's our x value, right? So we'll plug that into our equation to find the y value. So I'm going to come up here where I have some room and I don't have to bend down. So we're typing it in right here. Negative 16 times 1.03125 squared plus 33 times 1.03125 plus 46. So our maximum height is going to be this y value. What? Yes.
Easier just to put that into a fraction and do it.
I mean, the decimal is just as easy as a fraction in my opinion, but if you feel more confident with the fraction, absolutely go ahead. 62.98. So understand, guys, at 1.03125 seconds, so that's why I like the decimal. It makes more sense to say that in seconds, right? Instead of 3/4 seconds. Does that make sense? So 1.03125 seconds, it reaches its maximum height of 62.98. So if it asks for the maximum height, we just do the y values. That's the height. Does that make sense? If it said how long, when we use this, isn't this the seconds? Does that make sense, everybody? So our maximum height, this is C. Okay, so we have 2 answers here. All right, so I need you to finish the front page of the worksheet, as well as problem 20. The front page of the worksheet as well as problem 20.
What about the rest of it?
I'm going to add on to that problem number 19. No different than anything else we've done.